PGE's seminars and webinars are in part sponsored by Energy Trust of Oregon. We work together to make sure the concepts and recommendations you learn in our events are consistent across all of our individual programs and services. So as the title explains here, there's an introduction to energy monitoring, and we will talk about some opportunities to identify ways to save energy as you look at the information that you examine. Here's the agenda that we're going to go through today. We'll talk about the plan, and in the plan, we'll look at an overview. We'll talk about how we can gather some information, what type of information we need to gather. We'll take a look at the energy information that we do gather and evaluate how our facility is using energy and how we might be able to make some changes to reduce energy consumption. And then at the end, we'll address some additional resources, and then we'll summarize everything and go over some next steps for you. So here we are. We're going to talk about the plan now. Before I talk about the plan, I'd like to ask you a few questions, and the first one is select the best job that describes what you do every day. And feel free to use the tools up at the top left-hand side of the screen there to mark in. We've got a consultant in attendance. That's good. We've got an HVAC technician, facilities manager, sustainability manager, or coordinator. Okay, so we've got a broad range of people in attendance, and it looks like energy manager showed up there. I appreciate that input. I'm going to have you have several opportunities for input through the presentation, so I appreciate you chiming in now, and I thank you in advance for your participation later too. So why are you attending this webinar? Do you have a mandate for energy reduction? Do you need to benchmark your facility? Check all the boxes that apply to you. So we've got some mandates for energy reduction. I've worked with lots of customers that have a mandate, and sometimes there is some guidance from above, and sometimes there isn't. Regardless of whether or not you've got some guidance on how to proceed, energy monitoring can be a way to help you identify some projects. Sustainability is also looks like it's very popular, and we've got LEED and Energy Star. So basically all the boxes are checked, and again, this kind of just goes to show that we've got a wide variety of attendees today, and as the name of the course suggests, this is going to be an introduction just to give you a feel for what is involved in energy management and what are some of the tools and some of the results you can get. You may end up, after attending this webinar, with some more questions, and in the future there are opportunities for you to get some of those questions answered by attending seminars or other education events that PGE puts on, and we'll talk more about that later too. So here we are in the plan. We need to gather information, and that usually means we're going to collect and track utility bills in some form or another. We're going to consider interval metering data, and we want to document how we operate our building so that we know, what time of day equipment comes on and how that might manifest itself in energy consumption. We're going to talk about how we use the data and evaluate the data, and almost equally important, we need to document changes as we make them to make sure that the changes that we make are affecting our energy use the way we would expect. So collect and track utility bills. When you're gathering information on utility bills, it helps to know what are some of the terms and what are the important pieces of information that you want to gather. The biggest thing for an electric bill is energy use. On your electric bill, it's going to be based on kWh, which is kilowatt hours of consumption. Energy charges are likely the biggest part of your utility bill, and so they're associated with a kWh of use. To put that into perspective, let's talk about a 100-watt light bulb. When you turn that on, you need 100 watts of power. If you turn 10 of those on, you need 1,000 watts or 1 kilowatt of power. And if you leave those lights on for an hour, you will consume 1 kilowatt hour of energy. That's 1 kilowatt used on average over a total time period of 1 hour. The next biggest charge on your electric bill anyway, typically is a demand charge, and that's related to what's my peak power requirement. If, for example, we have that case where we have those 10 100-watt light bulbs and that's all we have on our meter, then our demand is going to be 1 kW. The key thing to keep in mind is, in PGE territory anyway, the demand that shows up on your bill is not an instantaneous demand. It's not your peak at any given time during the month. It's actually the highest average power consumption over a 30-minute period. We've got some customers with a lot of larger motors, and they are worried about turning them on and the high amp required as you start a bunch of large motors. But many times it's their steady consumption of power that ends up affecting their demand and their demand charges. And I don't want to get too much into the weeds, but you can learn more about that information at other seminars and webinars too. One last item on your bill is and it's not going to appear on everyone's bill, but it's potentially on your bill is going to be a reactive demand charge. This is usually a very small portion of your bill. Basically, it's how the electric system reacts to inductive or magnetic loads in the system. Magnetic fields will push amps out of phase with voltage, which causes you to use more amps than you need. You end up spitting amps back into our system, and we have to clean them up. And that's the quick rundown on reactive demand and kVAR. And there's a lot of information out there if you want to read more. But like I said, it's usually a small portion of your bill, and we'll see that as an example here coming up real quick. Here's an example of a Schedule 38 bill. In this case, this customer consumes over 30 kW or has a peak demand of over 30 kW at least twice a year, and that puts them in Schedule 83. There's a lot of information that shows up on your bill, but when you're talking about tracking energy consumption and the costs related with it, one of the big things is to look at your total charges for the month. Another important factor to look into is how many days we're in the metered period. You know, sometimes in this case it's 29 days, other times it could be as high as 33, it can be as low as 28, and it can vary from month to month and bill to bill. And so sometimes when you see an increase in kWh consumption, it could be just because that you've got more days of service in that given bill compared to the previous bill. And some of these factors are the things you need to consider as you're monitoring energy consumption. Moving on to more details in the bill, the bulk of the charges on your bill are going to show up in a PGE bill anyway on what I would call the second page. And we have a basic charge. Yeah.
Hey, Greg, this is Beth. I just have a quick request from one of our participants. Could you change your highlighter color? It's hard to see the text when you use that green color.
Yeah, believe it or not, I just clicked over to yellow, so I will do that.
Thanks.
So energy charges show up, and that's basically, regardless of how much you consume in the month, that's the cost of, you know, maintaining your meter, getting the billing out. And so regardless of your usage, your Schedule 38 customer is going to pay $40 per month, but that's just a fraction of the total bill amount. As I said before, the largest portion of your bill is typically going to be energy-related charges, and that's kWh. And in this case, we've got 3 different charges, and they make up 76% of the bill. Demand charges are the next biggest chunk, and they're about 13.2%. And buried in here, we also have a reactive demand charge. And like I said, for the vast majority of customers, this is a relatively small charge compared to the rest of the charges on your bill. What this charge allows us to do as PGE is to offer you and maintain good quality power service to you. When you spit those amps back at us out of phase with voltage, we have to get capacitors into our system to make sure that we can get that amperage back into phase and make it useful for you. And as you may note, all these charges together, these percentages don't add up to 100% because there are some adjustments, and we'll get into those adjustments here next. The adjustments show up on the third page of the bill, and these are adjustments that need to be made in between rate cases. PGE will go through a rate case where we estimate power demand and cost of power over the course of multiple years of operation, and then we use that to determine how much we're going to charge for energy for different schedules on our service. And there are things that take place in between those rate those rates, in between establishing those rates. The rate process requires review by the OPUC and review by community groups to make sure that we're offering you power at a reasonable price, and we're all for doing that. And so during the course of operating in between major rate changes, we often need to make some adjustments. So one example of an adjustment shows up here is Boardman decommissioning. This is when we're planning on taking our Boardman coal plant out of commission in 2020, and that's ahead of schedule. So in previous rate cases, we had built in what's the expected life of Boardman, and it was beyond the year 2020. So now we have to recover some costs associated with shutting Boardman down before we were planning to. And then also we have city taxes, low-income assistance, and public purpose charge. A good chunk of this public purpose charge goes over to the Energy Trust of Oregon and helps them offer incentives and technical assistance for PGE customers to do and implement energy efficiency projects and renewable energy projects. So that's the funding source for the Energy Trust. And if you're not familiar with the program, feel free to talk to some of the resources that we're going to bring to your attention here towards the end of the presentation. So if you've gone through and carefully logged your energy consumption over the years from month to month, you might end up with a spreadsheet that looks something like this. In this case, we've got the year 2000, 2012, and 2013. By going through a relatively simple task of documenting monthly consumption and calculating total annual energy consumption, you can start to see trends over time. So for example, in 2011, my consumption was under 100,000, and now I'm well over 100,000 in 2013. So that gives me an opportunity to ask some questions. Did I expand the square footage of my facility? Have I changed my hours of operation? Does that make sense, or do I need to dig into some more details and ask some more questions, possibly ask more questions of other people that I work with to help understand why my energy use went up and how I might be able to control energy consumption better in the future. So we want to gather consumption data from past bills. Here's an example of what a customer might see if they do that over a period of time. And so instead of just showing numbers on a chart, you may want to graph it. And in this case, you want to look at kWh per day. The way you calculate that is you have your monthly kWh consumption that shows up on your bill, and you divide it by the number of days in the billing cycle, and you plot those. In this case, we can see something happened in March of 2013. Energy consumption was following a trend over the course of the years that had a relatively high peak, and we see a drastic dip in consumption followed by an increase over the following months. So what happened here? Well, in this case, this customer installed some energy efficient lighting, and this is an example of how energy tracking and energy monitoring, even as simple as monthly bill analysis and documentation, can help you prove that you are getting savings from an energy efficiency project. And I want to remind everyone here that when you want to request incentives for an energy efficiency project through the Energy Trust of Oregon, many times you need to get the projects pre-approved. So it really pays to talk to your resources. Again, I'm going to bring those up later on in the program, and learn about what incentives are out there before you go ahead and move forward with a project. I've shown you why you may want to track your monthly energy consumption, and I've shown you how you might do it, but the question is, who has time for it, right? You need to get a copy of your bill, you need to enter the data in a spreadsheet, you repeat it, and maybe you dig through some old files and put some old consumption information in there. And that can be time well spent, but it may be time that you don't currently have available to you. So one approach would be to log on to your utility's website. In PGE's case, you go to portlandgeneral.com, and all you need to do is get a copy of one of your bills. And you need a copy of your bill so you have your account number. If you have your account number and some other specific details about your operation that should be readily available if you have spent any time in your facility, you can easily and quickly log into our system and register your account and download past data up to 3 years worth of monthly energy consumption, and it spits it out into a format that is easily input into any spreadsheet that you want to do. So again, log on to the utility's website, in our case, portlandgeneral.com. I know Northwest Natural has a similar function, and many other utilities have that ability as well. Once you have your monthly energy use over the period of 1 year, you can start to see trends over time. In this case, we've got a customer who has a peak that occurs in August. It's likely due to their heating and cooling, or specifically their cooling system, their HVAC cooling functions, and then tapers off in the wintertime to a relatively steady amount. But here's an example. This graph itself, you can quickly get this by just looking at one of your bills. And I'm going to erase things here so I can start over. So if you don't even have time to log in to the utility's website and register your account and download monthly data, you can just kind of draw a quick line for yourself. If you draw a line that appears to be roughly the average energy consumption for the full year, in this case I'm saying on average it's about 1,420 kilowatt hours per day. You do some quick math, and you can come up with your total annual energy consumption. And so this is a really quick way to get a pretty good estimate. In this case, we're within 2% of the actual data by just drawing this quick line and doing a quick calculation. So if you don't have time to do anything else, do this. And maybe do this once a year and see how you're faring over the years. Maybe your energy consumption is going down, or maybe it's going up, and then even by doing this quick calculation, you can start to be able to draw attention to times of the year or different changes in your operation that may require you to focus more or less on energy efficiency. Here's another method you could try out if all you do is have access to one utility bill. In this case, we're going to talk about HVAC load and how it manifests itself in a typical bill. As we pointed out before, we've got this graph over here that shows basically 12 months of energy use on a monthly basis, measured in kilowatt hours per day. And as a function of this, we've got some lighting, we've got plug loads, we've got all these loads that are what I would call base load in the system. Then above that, we've got some variable loads, which would be our heating systems and our cooling systems, and maybe fans associated with those. And I'm talking mainly, this is mainly geared towards commercial type operation. If you look at that, we would have some patterns that you would typically see. So if you draw a line at your base and you notice that you are typically consuming the same amount of energy for the first few months out of the year, like in this case, it's about 4 months, almost 5 months of pretty flat energy use. This is a good indicator that you have economizers in your HVAC system. And what economizer does is it allows you to use outside air for cooling rather than relying on a compressor in an HVAC system to do what I would call mechanical cooling. Again, the telltale sign of economizer operation is in the winter months when it's cooler, when it's less than about 55 degrees on average outside, that 55-degree air is more than enough to cool most commercial facilities. But let's go a few steps further and do some more analysis. Typically, if you have an operating economizer, your peak consumption is going to be about 25% more than your base, or if you multiply your base kWh per day by 1.25, that's typically where your peak's going to end up. So let's apply that to this bill over here. I've drawn a line here that roughly estimates what my base consumption is, what my winter consumption is, and that's 140. My peak is 171. So you do some quick math, you come up with 1.22. So my peak consumption is 22% more than my base consumption. From this, we can pretty confidently say, hey, it looks like my economizers in my HVAC system are functioning. Let's look at a different case. So this would be an example of what happens if economizers aren't functioning or aren't present in HVAC systems. Unlike before, we begin to increase energy use even in what I would call the shoulder months, the months that are relatively cool outside but not as cold as winter. And then how does that manifest itself? Well, in our case, and this is a typo here, I apologize, our base is here. Ignore the 75%. Our base is here, and our peak is actually 1.33 or 33% more than our base. And that's because our compressors in our HVAC system are working a lot harder than they would normally because they're not taking full advantage of bringing in outside air for cooling. So everything I've highlighted here is based on a typical generic application. Let's take a look at how it would show up in an actual utility bill.
Hey, Greg.
Yeah.
Before you proceed, and maybe after you're done with that next step, can you address any good tips for reducing the base load?
Yeah. I'll tackle that before I move on here. So base load would cover not only lights and plug loads, but also, any HVAC equipment that would run regardless of time of the year. So typically, your HVAC system, your fans moving the air within your building are going to run whenever people are present in the building. So that I would call base load. So with those three relatively big components, here's how you can make some reductions, okay? Turn off your lights when you're not needing them, maybe install some occupancy sensors, and that's a great opportunity to take advantage of Energy Trust incentives and technical assistance. There's often money available for that retrofit. Make sure you're scheduling your HVAC systems properly. I've seen sometimes when fans, for example, aren't being shut off in the evening or set back your thermostat temperature set points. You don't need to maintain a 70-degree building when nobody's in the building, and you don't need to bring in outside air and condition that outside air if nobody's in the building. But you do need to bring in outside air when people are there. So that most of the year, that outside air can be a significant load on your building as well. So base load would be, things that are always on, or another example of base load would be a electric hot water heater. If you don't need 140 degrees and you can get by with 120 degrees on your hot water supply temperature, if you make that reduction, if you reduce that set point temperature, you're going to reduce your base load in your building. Those are just some examples, and I know I could blather on some more, but I'll get back to the presentation. So here's how you might take a look at a building consumption pattern and analyze whether or not you have an economizer. So in our case, this actual building consumed as a base load 225 kWh per day. Our peak is at 309. We do the math, and we find out that our peak is 37% higher than our base. And thinking back and remembering how a good functioning economizer manifests itself, if an economizer is working, we would expect a peak of about 25%. And these are just round numbers, but we can definitely see a drastic change. And we can also see some periods of use in, the November time frame, and it's a little bit hard to see here, but there also would appear to be some times in the shoulder months where we've got some consumption that may be lower if we could get our economizer to function properly or optimally. So that's another good point that I should remind everyone of. Not all HVAC systems have the ability to have economizers integrated into them, and not all HVAC systems actually have economizers. But just because you don't have one doesn't mean you can't have one, and just because you have one doesn't mean it's going to be functioning properly. So this may be a method and a relatively quick calculation you can do over a period of time to make sure that your economizer is functioning. And an economizer typically will have thermostats and potentially multiple thermostats and multiple dampers, so multiple modes of failure. I recall reading a study out there that indicated roughly 75% of all active economizers are not currently functioning at any given time. So it's definitely something to keep your eye on if you've got the time to do this relatively quick analysis. Let's go back and look at that retail customer that did that lighting project. Even if you don't have a copy of your bill, you can go back to your data and do the same analysis. In this case, we draw a line at our base, we draw a line at our peak, do the calc. We're at 1.26, or our peak is 26% higher than our base. The economizer appears to be functioning, but there are some things to look for. It looks like we've got some time here in the shoulder seasons where our energy consumption is higher than it would be if we had an optimal economizer. Now, there may be some other reasons for this. This retail customer may have some high hours of operation during the holiday season, and that may account for some additional energy use, and either in the HVAC system or even in lighting or other systems too. So just because you see a trend that looks like, hey, my economizer is not working, it's not always your economizer that's causing an increase in energy consumption. So here we are in the process here. We've talked about tracking utility bills over time, and it's the first step in the process. And like I said, if you do nothing else in the course of implementing rudimentary energy monitoring, I recommend that you at least do some of that quick analysis with one bill and see how that works for you over time. So now we're going to move on to the next step. And that is, do I want more information than a simple monthly bill can offer me? When we talk about interval metering, we're talking about metering energy use over a given period of time. And your monthly bill is an interval metering opportunity. It's energy consumption over roughly a 1 month period. But there are opportunities for you to take a look at smaller intervals, maybe 15 minutes, half hour energy use, and that can allow you to take a more granular look at your energy consumption and look for even more opportunities for energy efficiency improvement. So I've already addressed most of the information on this slide. And so typically, yeah, when we're talking about investing time, because it is an investment in time, right? We've got more data that we have to look through. It may cost us money to get that data in a form that works for us. If we're a small company that has $100, $200 per month of energy consumption or somewhere in that range, we may not want to invest a whole lot of money in energy interval metering. But if we're a property manager with multiple facilities that we need to keep track of, and maybe we don't have time to physically look at every single bill for every single facility we have. Interval metering can be a good tool for you to use to track your consumption over time and look for opportunities. Typically 1 hour is useful. 15 minutes is probably the best you're going to get, and there are benefits to both. We'll talk about that a little bit here. Before I move on, I'd like to ask you a question, and again, we can use the tools at the top of the screen here. Please circle which part or indicate, which one of the following is not part of the gathering information step. Yeah, so it looks like we're all looking at drawing the load shape. And then we've got some people that have marked repeat once a month for years. So technically, repetition is part of the gathering of information step, although you may find that over time your facility isn't making many operational changes, so maybe you don't need to repeat the steps once a month. But typically, if you're going to be investing some time in tracking energy use, you want to keep it up over a period of time. So drawing your load shape, yeah, that's definitely what I would say is not part of the gathering information step, but it is still a definitely useful part of the process, and I'm going to go into a little bit more detail here in a little bit on what that entails, the drawing of your load shape. So now we're moving on. We're still talking about the plan, the energy monitoring plan, but now we're going to talk about using energy data and evaluating the data and documenting changes made. I'm going to draw for you the load shape at my home over the course of a typical day. So let's start here in the morning hours. Everyone's asleep. Maybe my alarm goes off at 4 and I hit snooze. So our consumption is still pretty low. And maybe there's a little bit of wavering action in the consumption, but it's the refrigerator cycling on and off. By 5:30, I need to be up. So I turn on some lights, and by 6 o'clock, I realize I didn't iron my pants. So I throw my laundry into the dryer, and my consumption goes up to, let's say, roughly 10 kW for a very short period of time. And then everybody else is getting up in the house and turning on lights, and we're making coffee. And by 10 o'clock, we settle back into a period of low energy consumption. And then dinner time rolls around, and maybe we start the oven up and we see an increase, and then a legitimate load of laundry gets done, and then things taper off to our low energy consumption during the evening. So that's a load shape in my house that I might see, and things could change. Maybe we did 2 legitimate loads of laundry, but we can definitely see patterns of consumption, and with patterns of consumption, we can find some opportunities for savings. So, for example, right here, maybe I should make a effort to use an iron rather than throwing my pants into the dryer, but it works for me, so I continue to do that. Now's your opportunity, and I know we've got quite a few people in attendance today, so this might get messy, but I'm totally willing to give it a try. So use your tools, maybe use your highlighter tool, and draw what your load shape might look like. Don't worry about the units over here, but I have thrown in some units. Okay, we've got some participation. This is good. And so if you would, please just hopefully I can get a couple examples of a total day's worth of consumption at a facility that you're working at. So the green line is a relatively low consumption point, and okay, so let's talk about the blue line. That could be a seasonal operation of sorts. Maybe it's a residence again. The cyan line that just came up, that could be a manufacturing facility because it's got a relatively high consumption throughout the day, and then we've got some peaks and troughs. The troughs may occur when we've got breaks and whatnot. Maybe it's a lunchtime break, and then we got our second shift starting, and then our nighttime shift doesn't use as much. So that magenta line that just came up is going to be more like the line I'm going to show you. Thank you very much for your participation on that. I know I could have addressed more of those shapes, but I think I'd like to move on here right now. This would be a pattern that you would typically see in an office building, a relatively large office building, right? Because we've got a nighttime consumption of over 300 kW. And then energy consumption increases. I'm going to delete my marker here so I can use the clean marks that I've got here coming up. When we look at a daily load shape, it has some ups and downs and some wiggles to it, but it's often helpful to break it into chunks. So here we have a chunk of time, roughly 4 hours, where we're at an average of 330 kW. Then we have this morning warm-up time where maybe the HVAC systems are kicking on, lights are being turned on automatically, maybe, or maybe people are actually arriving into the building, but the building's not fully occupied yet. And then we have a period of use, what I would call, regular use, the 9 to 5ers, or your operation may be 8 to 7, but there's going to be typically a period of relatively high demand in a commercial environment, followed by a tapering period, and then your evening period. By looking at this daily use, we can estimate what our daily consumption is by adding up all that multiplication that we had. So we add up the area basically under the curve to come up with our energy use, because our curve is measuring our kW use, our power consumption, and it's over a period of time. So power times time is energy. And so in this case, this customer used just over 17,000 kilowatt hours in one day. Oh, sorry. So here's the plan. Maybe when you look at your daily energy use, you determine that you're starting up your systems too soon. Your HVAC systems are coming on at 4 and warming up the space by 5, but nobody's there until 7. So maybe you stagger you delay the start of your HVAC systems or your automatic lighting systems or whatever. Maybe things are taking too long to shut down when you vacate the building. And then weekends should be very different than weekdays if you're a typical commercial operation. Or at any rate, weekends may have a different shape to them. Even if you are a 24/7 operation, maybe you've got lower production rates during the weekends or things of that nature. So just because I'm talking about commercial operations doesn't mean that interval information is not useful for industrial facilities. You can often see trends that would indicate the startup of, let's say, a chiller. Oftentimes, in the summertime, we may see a peak in consumption, or at least a jump in consumption around 3 o'clock when the temperature outside is starting to get really warm. Another chiller may be coming on, and that you will usually show up as a very distinct line and a distinct increase in energy consumption. And it gives you an opportunity to make sure your controls are programmed correctly. And then taking into account all these factors, we have the opportunity then to make corrective action, right? If we determine that we're starting up too soon, we can change set points, and then we need to follow up on other days to see that we have indeed reduced our early morning energy consumption. PGE has a tool, and there are other providers of tools out there that can give you graphical representation and require you to do less of your own analysis to determine, trends in your energy consumption, and they can give you a daily scorecard, which I'll show you here in a little bit. They'll show you your monthly load profiles, and you can do multiple types of charts, either based on production or temperature, or maybe you can do what's called a cumulative summary chart, which will often show you the energy savings that you can get from energy efficiency projects. And I'm not going to talk too much about QSUM charts here, but it's definitely a topic in the seminars that will be coming up. So here's an example of a scorecard that you might get for, in this case, it's Energy Expert, but like I said, there are some other providers out there that have similar opportunities. At a glance, you can see the date that this applies to. This is a January date in 2008. We've got an indication here that our energy consumption is high. Energy Expert and other tools allow you to look at your energy consumption and compare it to other factors, including temperature. In this case, this high day occurred when the low temperature outside was 24 degrees and the high temperature was 41, so relatively cold day that you might expect in January. Our peak energy consumption occurred here just before noon, just after 10 actually. And that in and of itself may give you some indication. As we can see down here, this is a depiction of the load shape of the day. And we can definitely see a peak has occurred earlier in the day, and that could indicate that maybe your heating systems were working a little bit hard to recover from cooling down the night before. The scorecard also gives you an opportunity to see what might be happening in your future. In this case, the high energy use happened on a Wednesday, and this report card is telling me that if I don't make any changes to my system, the weather is expected to be very similar tomorrow, and we might expect to see another high day tomorrow. For whatever reason, maybe our Friday use is always relatively low. It's indicating that our weekend and our Friday are likely to be more in the green, more typical. And that's at least partly due to the fact that the temperatures are expected to be warming up on those days. This report card also gives you an opportunity to document why a change has occurred in your system. And this could be an increase or it could be a decrease. So in this case, we've got a note where the fans and the boilers ran 24/7. Outside air temperature was a low of 27 and a high of 38. So they knew this day, they knew Wednesday was going to be cold, so on Tuesday they left their HVAC systems running to make sure that the building was comfortable for the occupants. And that then obviously resulted in high energy use for the day. Here's another way, another tool in the program. In this case, we're looking at a whole month, October of 2009, and we have a whole series of daily load shapes. And here's a case where you can look at, so here in Tuesday, I saw a jump in energy use. Now what we don't see here is scale, so this could be a large jump or it could be a small jump, but at any rate, it manifested itself as a jump, and we see that same jump here and here and here, and occasionally on following days. So even at a glance, we can get some quick information. So for example, Tuesday had a blue color here in the date, and that means energy consumption was relatively low based on the temperatures that we were seeing. Green means it's average, it's a typical day, typical Friday, a low Saturday. We had a high Sunday, and so maybe some systems were left on for whatever reason. Maybe there was some maintenance done on HVAC systems and the contractor needed to manually turn everything on and bypass controls. And we can see that potentially here in this graph where we've got a chunk of time where energy consumption started low but then ended up being high for a period of time and then went back low again. Sometimes when maintenance is done and controls are manually adjusted, they don't always get readjusted back to their mode of normal operation. And so even with a simple graph or a simple representation as this calendar, you can see some trends. If we saw that peak again happening on the following Sunday and the following Sunday, that's a good indication that, hey, something was done on likely the October 4th that continued on for several Sundays after that, for example. So which of the following is not a step in the plan? And this is one more opportunity for you to use the markers to indicate which of the following you think is not part of the plan. Thank you, everyone. Yes, so developing a capital improvement plan, I highly recommend it. It can often be a good, or energy monitoring and management can be a good tool to help you prioritize some capital improvements. And capital improvements, remember, could be some energy efficiency projects, and there could be some incentives for those. So it's definitely a good thing to consider, but it's definitely not part of the plan. So here's some of the additional resources that I mentioned, and there will be a few more here in the next slide here too. But if you are interested in Energy Expert, feel free to contact Will Miller, and I've got an email address for him and a phone number for him. And then, so in closing, I want to talk about the summary and next steps. One next step you can implement is go to portlandgeneral.com and look at Energy Tracker tool. It's a good tool for small businesses and residential customers. It gives you an opportunity to look at interval data, in less than 1 month increments, and look for trends in your energy use, and maybe look for opportunities to reduce your energy consumption. Execute the plan in your facility. Track your energy use, find trends that you think are some opportunities, and make some changes, and see if those changes then result in lower energy use, or at least a change in energy use that you would expect. There are some times when you'll see trends in your energy consumption, and it actually highlights a reason why you need to increase your energy consumption. So for example, I've definitely seen some people looking at their energy tracker information and realizing that they don't have enough capacity in their HVAC system. And maybe the energy tracking wasn't the only clue that they had, but for example, if their energy consumption on a really hot day is very similar to their consumption on a warm day, that may be the result of your system not providing enough cooling capacity for your building. Then also keep in mind, and I think I mentioned it several times already, but I'll mention it again, many Energy Trust opportunities and many opportunities with other incentive providers in other states or other regions require you to pre-approve projects before you invest in making adjustments. So contact your resources, and I'm going to have some numbers here in the next slide. But regardless, feel free to contact PGE for free assistance with incentive programs. Here are your energy efficiency resources. Of course, PGE and Energy Trust provide free consultations by phone or on site to help identify energy savings. And to learn more, you can visit portlandgeneral.com. If you're a commercial customer, you can call Paula Conway. If you're an industrial customer, call Darren Spencer, and they'll get you on the right track to implement energy efficiency projects. If you're not with PGE, just contact your local utility, and they will more than likely help you in a similar fashion. With that, I think I'll hand it off to Beth.
Thank you, Greg. Before we proceed to the question and answer portion of today's webinar, I'd like to remind you that you can continue to submit questions to me through chat, and I can ask them out loud if you'd like, or you can go ahead, or I can unmute you and you can ask them. Our first question, Greg, is, there's been debate about whether it's better to let your AC unit cycle on and off as needed versus holding it until the outside temp reaches a steady high, then running the AC continuously. What do you recommend as the best energy saving practice?
Yeah, I would say, anytime you make changes to your controls for a short window of time, it's a opportunity, or there's a chance that you might not change them back to their normal operation when the situation changes. So in the example of, when it's warm outside, I'll run my system 24/7, and that's totally fine. We see people do that all the time. The key is make sure you turn your systems back to normal operation when temperatures resume back to normal. I definitely recommend you to, under normal situations, especially in commercial and residential applications, set back your temperatures when your space is not occupied, or in the case of a residence, when you're asleep at night, relax your temperature set points. So in the summertime, we're talking about maybe changing our air conditioning temperature set point from 70 during the day to 80 at night. And then in the wintertime, 70 or so, 68 down to 60 at night. Yes, there's going to be some energy consumption that happens when you wake up in the morning or when you come back into the building and you require the system to come back to your normal daily operation set point. But that total energy consumption is typically going to be less than if you were to have left your systems at 70 degrees all the time.
Thanks, Greg. And our next question is, what rules of thumb can I use when looking at my energy consumption information to help me determine if I need to make some changes?
Mm-hmm. So guidelines are just that. They're guidelines, and your mileage may vary. But one thing to keep in mind is that, you know, a typical office building, especially one that has gas heating, will need about 4 watts per square foot. So if you know the total square footage of your building, you multiply that by 4 and divide by 1,000 to get it into kilowatts total. And keep in mind, that's going to be your peak, and your peak is typically going to happen in the summertime. So the rule of thumb is, yeah, 4 watts per square foot is in the ballpark. If you're more than that, you know, maybe you have some computer systems or other things, other critical equipment that requires power, more power than that, and those are things that you got to keep in mind. Another rule of thumb is, I believe Energy Star and other sources suggest that you should only set back your thermostat, like I talked about, if you're going to be at that set point for about 8 hours. So definitely, when you're talking about a residential customer, set back your thermostat at night. You're going to sleep through the night. Hopefully, you're getting your 8 hours of sleep, and that's a great opportunity to take advantage of setting the temperature back. But if you're a system that's operating, or if you're in a building that's operating 20 hours a day, maybe you don't want to set back your thermostats for the 4-hour window that you have of low occupancy. Those are just some quick rules of thumb. There are more out there, but the ability for you to act on those is definitely going to depend on, you know, what you need in your system and what type of systems you have. For example, many times, especially with older heat pump systems, we don't recommend you to set back your temperatures because it actually takes a lot more energy to use the auxiliary heat in those in the wintertime to warm things back up.
Great, thanks, Greg. And we do have some additional questions which we will get answered offline and send to you all with the follow-up materials. That was the final question, and I'd like to thank you for joining us today.